We're Group 13, and this is problem 9.9. And it's a truss system with 300 pounds, 500 pounds, and 600 pounds. And here is a pin with and this is a roller, each all separated by 3 feet. And we're going to be using virtual work to solve the problem. We're going to determine the vertical displacement at point F and assume all numbers are pin connected. Coming over here, we apply the 1 pound load at point F, and there's a force in the x direction at F, and then there's a force in the y in the x direction at C. And we take the moment about C, and we find that the force at x is 2 pounds, and then we take the sum of the forces in the x direction on the truss, and we find out that C in the x is equal to 2 pounds as well in the opposite direction. Coming over here, we're using the method of joints at point F, and we know that there's already a 2 pound force that is Fx, and there's the 1 pound force that we applied, and we take, you sum the forces in the x and the y, and you find that the force at EF is 2 pounds in compression, and the force at AF is 1 pound in compression. And then you do the same thing at point A, and you find that F of AE in the y is going to equal to 1 pound. So you find out that FAE is equal to 1.14 pounds in tension, and you find that FAE in x is going to equal FAB, which it means that FAB will equal 1 pound in compression. Alright, moving on with the virtual work problem, we take the sum of the forces in the y, and we see that the force 1.14 is going to be, in the y direction, is going to be equal to FBE in the y direction, which gives us 1 pound. And then we take a sum of the forces in the x, and we find that FDE is equal to 1 pound of compression, in compression. Moving on, we go to point D, and we see that FC in the D, FCD is equal to FBD in the y. So we find that FCD is equal to 1 pound in compression, and then FBD in the x is equal to 1 pound. So we find that FBD is equal to 1.14 pounds in tension. Moving on, at point C, we see that FBC is equal to 2 pounds in compression by that force there.
Alright, now we're going to find the forces using the actual applied load. We got 500 pounds joint D and 300 at D, 500 E. To find the reactions, we're going to sum the moments around point C to find the reaction at F. Sum of the moments, you find F of x is 1,700 pounds. Then summing the forces in the x and summing the forces in the y will give you the reaction to Cx and Cy. And we're going to go down to the method of joints. Start off with joint F. By inspection, just summing the forces again will give you F of EF and FAF. Move down to joint A. We knew FAF coming in, and that will give the force of 600 pounds coming down. Using the sum of the forces in the y, you can find the y component for F of AE, and you find the y component, and FAE comes out to 848.53 in tension. And then take the x component of that and set that equal to F of AB, and you get 600 pounds in compression. Goes over to joint E next. By inspection, just summing the forces in the x. The x component of the 848 plus the 1,700 pounds, it gives you the FDE, which is 1,100 pounds in compression. And then with the forces in the y, taking the y component of FAE and the y component coming in will give you FBE, which is 1,100 pounds in compression. All right, and we got our last two joints here. Joint D, inspection again. You can find the x component of FBD from 1,100 pounds into the joint. F of x finds FBD is 1555.63 in tension, and then use the y component in that with 300 pounds to find the FCD. FCD is 1,400 pounds in compression. We're going to come over here to C and use the FCD coming in plus the force of the Y coming out, coming into the board or into the joint. Those cancel out. You know we're good there. And FBC by inspection, saw the force in the X is equal to 1,700 pounds in compression.
Next, we want to use our virtual work equation, and since we applied a load of 1 pound, we can just take that out of there. So then we get the vertical displacement at F is equal to the summation of your virtual forces times your real forces times the length all over your area times your E value. So then taking all of our values that we found, we arrange them in this table. You have all of your 9 members, and then you have your virtual forces, which is little n, and then you have your real forces, and then the length of each member. And all of the members are the same 3 feet except for 2 of them. And going back to the original drawing, since both sides are 3 feet, you can use the Pythagorean theorem to find that this length here is 4.243 feet. So then that's for members AE and BD. And then this last column, you just simply multiply all of these 3 columns together all the way across. And then finally you'll come down here and sum the entire last column. You get 47,424 pounds squared feet. And then so finally plugging that into our virtual work equation, you have the displacement, the vertical displacement at point F is equal to this value, which we just found from the table. And since that was in pounds squared feet and we need it in inches, we need to multiply times 12. And then it's all over the area, which was given half an inch squared, and then times E, which was given as 29 times 10 to the third KSI, but we want it in PSI, so we have to multiply it by another 10 to the third. So once you do the final calculation, you get the final vertical displacement at F to be 0.0392 inches.